Hello, my name is Jesse White, and this is my Cat 2 assignment for Kin 516, and it's the fate of lactate. Go ahead and jump right in. So the main thing we're going to look at with the pathway of lactate moving through and its metabolism process is broken down pretty much in the simplest terms that I could find. Glucose to lactate with the blood taxi, and then lactate to glucose. And as we move forward, we'll break down that process. But I thought this was a really good illustration of just how that muscle is dropping off that lactate into the bloodstream, which is being pushed into the liver. Then gluconeogenesis takes effect and then pushes that glucose back through the blood system, back to the muscles. So for the breakdown, this really starts with the glycolysis process within the muscle. So the determining factor that's going to drive how that lactate is pushed out is the presence of oxygen. If there's enough presence, excuse me, if there's enough oxygen present, it's just going to follow through with that normal Krebs cycle and push through. But if there's not enough, or there's no oxygen present and that anaerobic process has started, there's going to be that production of lactate. So that pyruvate will drop off into lactate, which will get pushed into the bloodstream and transferred into the liver and partly the kidneys. So once it's there, again, that gluconeogenesis process is going to start. It's going to take in the lactate and convert that back into glucose and then push that back out through the bloodstream back into the muscle. So it's a constant ebb and flow. Some effects that could, alter this. Again, is going to be the intensity, type, and duration of the actual exercise you're doing. So again, if it's that anaerobic exercise that's going to have no high levels of oxygen present, it's going to, drive the further increase of lactate in the system, which will accumulate. And if it's more aerobic, there's going to be less of that. So there's going to be more oxygen available to push it through to the Krebs. So another big thing McArdle et al. 2015 was pointing out was the ability of accumulation and turnover. So accumulation is the amount of lactate that's pushed into the bloodstream, and then turnover being that flushing effect of getting that lactate out of the bloodstream into the liver, processed and pushed into glucose, and then fed back into the muscle systems itself. And oxygen supply and respiratory chain limitations are going to be the things that affect that ability and the efficiency of that flow. Looking at lactate versus lactic acid, what it really breaks down to is just that hydrogen ion. So the hydrogen ion is what technically makes lactate, which is a base, not an acid, an acid. So very similar, but they're not the same. Lactate is produced again by that glycolysis process with a low oxygen availability and push into lactate. It's not the enemy. There's been a lot of studies, or not studies, but beliefs in the past that the causation does not equal correlation. That's kind of what was happening here. They were seeing a lot of accumulation with studies of lactate, and then that buildup of muscle fatigue and the failure to continue with exercise. So they were saying that they believed that was the cause of it, but as we know now, that's not really the case. Lactate is actually your friend with this, and it actually can pull on and take on those hydrogen and flush out the system even better. But lactate does accumulate in the bloodstream as we push forward, again, with those exercises. And as that level goes up, there's like a natural neutrality that the bloodstream likes to keep. And so as that level goes up, which is like, again, a base, the acidic side has to go up, which causes that drop in pH to create an acidic inhospitable environment, which most likely is what's actually causing that pain that's associated with the strain and stress of exercise. And back to the metabolic use. So with that Cori cycle, we're getting that gluconeogenesis, and then the lactate shuttling. So the movement of that lactate in and out of the liver and into the bloodstream and throughout the whole muscle system. That's what's going to, really cause that glycogen replenishment. So you're going to get the blood glucose elevated and then pushed back into the muscles. So that's just kind of how that ebb and flow works. It's just a continuous push. And this is happening all the time. This isn't something that only happens during anaerobic activity. It's just that once that point is reached, the proportion of like how this energy system is used starts to go up and is elevated. So without that oxygen, that low level situation is when you're going to see a rise in this like Cori cycle. And again, consequences of accumulation, kind of touched on it earlier. It's really a matter of homeostasis versus muscle acidosis. So the body wants to stay in a neutral balance at all times, and as these hydrogen ions and the lactate and everything goes into the blood system, it's that constant fight of trying to elevate and find that middle ground that it likes to stay at, where it's nice and neutral. And as the lactate goes in to the bloodstream and that level begins to accumulate because of the lack of efficiency for the whole system to do that flushing and replenishment of glucose and glycogen, those other pH levels are going to try to balance it out. And as that happens, you're going to get a drop in pH levels, which is going to create that inhospitable acidic environment, which is that muscle acidosis. And that is most likely what's causing that pain and the stress on the muscles that you feel when you're like pushing really hard and you get to the point where you can't go anymore and your legs are just burning. That's most likely the cause of the acidosis, the acidic environment that comes with that. And again, that's from the hydrogen ions and not the actual lactate itself. The lactate can actually take on those hydrogen ions and help with that situation because they're a taker as a base instead of a acidic that's looking. Other factors. So again, it comes down to really the efficiency of the flushing system itself, VO2 max and respiratory efficiency. So the body's ability to get in that oxygen, get in enough oxygen to push that glycogen stores through as energy. So that's another part of it to consider. And again, your fitness level, genetics, and muscle fiber types are really going to affect your body's efficiency and where your like blood lactate threshold is and how much lactate you can flush in and out of these systems. References for this, I just used the book that we have for this class, McArdle, and yeah, that's about it. If you'll have any questions, feel free to reach out. Thanks.